Hello, everybody. Today I'm going to be discussing my instruction manual on constructing phylogenetic trees from reference genome gene sequences. The purpose of this manual is to construct and compare phylogenetic trees of 8 species using an alignment of the cytochrome C oxidase 1 gene as well as the glyceraldehyde 3-phosphate dehydrogenase gene. And the phylogenetic tree construction will be done using the 8 package in R. So first of all, what is the relevance of this? Phylogenetics is very important for understanding the evolutionary history of life and understanding the relationships and the divergence of different species and what paths they have taken historically. And a very fundamental aspect of phylogenetics involves constructing phylogenetic trees, which are just a graphical representation of the evolutionary relationships. So in the instruction manual, the data used is FASTA files that were all obtained through the NCBI nucleotide database. And here I have a table showing all of the accession numbers for both the genes as well as for all the species. So what are the bioinformatic approaches that will be shown in the manual? Well, first, once we have all of our data, which is in a FASTA file, we are going to see how to align FASTA files. And this is done in the manual using the Clustal W tool. And this will output a Clustal format file, which we will then learn how to convert from the Clustal format to the aligned FASTA file. So back into the FASTA format. So now you have an aligned FASTA file. And from this aligned FASTA file, we will learn how to use the 8 package in R to be able to create a distance matrix. And then from the distance matrix, be able to create phylogenetic trees. So here I have shown a tree using the GADPH, the glyceraldehyde 3-phosphate phosphate dehydrogenase gene. And in the manual, you'll see this same tree as well as the COX-1 gene tree. And from the two trees, we can see that there were some differences in the trees. Mainly, you will see that there's a difference in the scale that indicates a difference in the distance between the evolution of the two genes. So because the scales are different, it means that the gene with the lower distance was more conserved, and over the history of the divergence of all these species, it has stayed more similar and had less of a distance between the gene sequences for all the species. So you can check out the manual to get a more in-depth analysis on the results of the two graphs, as well as a step-by-step on how this is actually done so that you can do it yourself. And thank you for listening.